Sunrises and sunsets. We all know them, we all admire them, but did you know that over the course of a year, the hours of daylight in comparison to the month actually create a sinusoidal function? In this video, I'm going to be explaining why that happens. In the graph below, you can see the hours of daylight over the course of a year. The peak of about 15.5 hours of daylight happen in June, and the minimum hours happen during December. On this graph, March 20th is the Northern Hemisphere's vernal equinox, where the day and night are approximately equal in hours. Also, if you see here from January to mid-June, the hours of daylight are at a rapid increase. And between late June and December, the hours of daylight are decreasing. Between June 20th and June 22nd, we have something called a summer solstice, sometimes called the June solstice, which is the longest day of the year. The summer solstice occurs in both the northern and southern hemispheres. This happens because the planet is most inclined towards the sun, and therefore we're receiving the most direct sunlight during that day, and that makes the day longer. So here is kind of a more in-depth map of the June solstice for 2017. So on this map, it shows the sunlight that is reaching whatever areas. So first you see the night where it's the darkest shade and there's no twilight. Then there is the astronomical twilight, which is the second shade up. Then there's the nautical twilight, which is the next shade up from that. And finally, there is the civil twilight, which is the lightest shade. And of course, then there's the areas that are getting sunlight. And over in the bottom right corner of China, you can see a sun symbol, which is where the sun's position is directly overhead in relation to the observer. And then to the left of that, around India, there is a moon symbol, which is where the moon's position is directly overhead to the observer. After the June solstice, the sun follows a lower and lower path through the sky each day until it reaches a point where the daylight is about 12 hours. This is called the September equinox, or sometimes it's called the autumnal equinox. Here everything is put together in relation to the sun. There is the June solstice, which opposite is December solstice, and then there's the September equinox, which has its opposite of the March equinox. So when we're graphing this, when you look at the June solstice, you can see that the hours of daylight are at its highest. At the December solstice, the hours of daylight are at its lowest because it has the least amount of direct sunlight. And you can see the September equinox and the March equinox, where the hours of daylight are almost exactly the same as the hours of moonlight. This graph will continue going on forever through the years, and therefore it is a continuous sinusoidal function. Thank you so much for watching. I hope you learned some about the sinusoidal function in relation to the daylight hours.